Have you ever really considered where all our waste disappears to? Especially in our incredibly dense cities, cities that just keep expanding. How do they keep growing without just being, well, overwhelmed by their own trash? It feels like a huge challenge, doesn't it?
It really does. A logistical nightmare sometimes.
Well, today we're doing a deep dive into a really innovative engineering solution that's tackling exactly this. Our mission basically is to unpack how this company, Strata Global, is approaching it. And interestingly, not by expanding outwards, the usual way.
Right, but often you just can't in crowded urban areas.
Exactly, so they're building up.
Yeah, and our source material for this, it comes straight from Strata Global themselves. So we get a good look into their geotechnical engineering work, their geosynthetic materials, all through their company profile, and some pretty specific project success stories that they've shared.
Okay, so get ready. We're going to explore how clever design and some advanced materials can create really surprising capacity and efficiency, too, turning what seems like this impossible urban problem into, well, an actual engineering solution. You might find yourself rethinking resource management a bit after this.
Yeah, it's pretty eye-opening stuff.
So, okay, let's unpack this specific case. The source material really focuses on one key example, a landfill in Vapi, Gujarat, India. The client there, Vapi Green Enviro Limited, they have this critical issue. They desperately needed more storage volume, like enough for at least 2 more years of waste.
And the crunch was this landfill was smack bang in a really congested zone, which meant horizontal expansion, just making the landfill wider, was incredibly expensive, probably practically impossible, really.
Right. So that raises the big question. How do you add capacity when you just can't spread out?
Exactly. What do you do then?
So when spreading out was off the table, what did Strata actually suggest? How did they manage to rethink something as fundamental as landfill expansion?
Well, this is where their, kind of out-of-the-box thinking really comes in. Instead of that conventional sprawl, they came up with a vertical solution, a containment system built using a reinforced soil structure.
Reinforced soil, okay.
Yeah, and the key thing they mentioned was creating a slim yet safe structure, the goal being to generate significantly more storage space vertically.
Okay, slim yet safe. So help me picture this. What would a conventional retaining structure have looked like for something this size? When we talk in like a massive concrete wall.
Oh, yeah, absolutely. Conventionally, for this kind of height and load, you'd probably be looking at a huge, bulky concrete gravity wall, maybe, which needs a massive footprint. Lots of excavation, tons of concrete, big material costs.
Right.
Strata's approach, using reinforced soil, means they're basically strengthening the soil itself internally, layer by layer, with geosynthetic grids. So they can build much steeper slopes, much more compactly. It maximizes the existing land because you don't need that huge external retaining structure taking up space. It's a fundamental shift, really.
That makes a lot of sense. So they're reinforcing the soil from within, essentially.
Precisely.
And how did they achieve that smart design? What were the specific bits, the technologies that let them build upwards so efficiently?
Okay, so the source mentions 2 of Strata's specific systems were used here, StrataSlope and StrataBlock.
StrataSlope.
Right, that formed the inner slope, the part right up against the landfill material itself. And the source describes it as a StrataGrid fascia, that's like the facing element wrapped around soil bags.
Soil bags, okay, so that's the inside layer.
But then, crucially, this interface was draped with a composite of geomembrane and non-woven geotextile.
Geomembrane.
Wow.
Right, that sounds important. Why?
Oh, it's absolutely vital. This layer prevents the landfill leachate, the contaminated liquid that drains from the waste.
Right, the nasty stuff.
Exactly. It stops that from seeping out into the containment structure or the surrounding ground. It's key for environmental protection, long-term stability, ecological safety, the works.
Okay, so if they hadn't put that geomembrane in, what's the worst case? Just leachate everywhere.
Pretty much. It could seep into the groundwater, contaminate the soil around the site. I mean, major environmental pollution. So yeah, that impermeable layer isn't just like a nice to have. It's absolutely non-negotiable for any modern, responsible landfill design.
Got it. Critical layer. Okay, so that's StrataSlope on the inside with the membrane. What about the other system, StrataBlock?
Right, StrataBlock. This was for the outside. It created what the source calls the aesthetically pleasing outer fascia.
The fortress look, maybe.
Maybe. It used precast segmental concrete blocks, like big modular concrete blocks, and these were connected internally back into the reinforced soil mass using StrataGrid and special keys or connectors.
So they're anchored back into the reinforced soil.
Exactly, which provides stability and, according to the source, a pretty maintenance-free structure once it's built.
Okay, that paints a clear picture. Inner slope, protective liner, outer block wall, all tied back into this reinforced soil mass.
You got it.
So what was the result? What did this mean in practice for Vapi Green Enviro and, for waste management there?
Well, the impact sounds pretty significant. By building India's first vertical landfill this way, Strata reported they increased the total dumping capacity by 2 times compared to conventional methods.
Wow, double the capacity on the same footprint, basically.
Essentially, yes. And the scale was considerable. The total fascia area, the face of the structure, was 6,600 square meters. That's quite large.
That's huge. And this project, it does more than just solve Vapi's problem, right? It says something about Strata's capabilities overall.
Definitely. The source uses this to highlight their broader expertise, as a global player in both geosynthetic manufacturing and geotechnical engineering. They mentioned having this team of over 200 engineers providing technical know-how, turnkey project support, and, importantly, aiming to keep costs down and finish projects on schedule, which is always critical in these big infrastructure jobs.
And it's not just landfills, is it? You mentioned this. Reinforced soil technology has wider uses.
Oh, absolutely. The source gives several other examples which are quite interesting, like slope retention work at Kubertila, near the Ram Mandir site, and a really tall, 32-meter high strata-webbed geocell wall project in Manipur.
Maybe 2 meters, that's tall.
Very tall. And the challenge there was stabilizing steep slopes where there was very limited right-of-way.
Meaning not much land available sideways to build a gradual slope.
Exactly. So again, they had to go vertical or near vertical.
Makes sense.
Any others?
Yeah, also constructing reinforced soil or RS wall approaches for the NH 363 highway.
Okay, so highways, religious sites, remote slip stabilization. Right. It really shows how this core idea, reinforcing soil to build steep structures, can tackle such different problems, whether it's containing city waste, holding up a highway embankment, or developing land in tricky terrain. It's adaptable across sectors like highways, railways, mining, general land development, you name it.
So we've taken quite the deep dive today. We looked at how this seemingly simple idea of building up instead of out can really revolutionize some big infrastructure challenges.
Yep.
From waste management and crowded cities to building roads through difficult landscapes. It really showcases the power of innovative geotechnical engineering.
Yeah, that Vapi vertical landfill project, it's a really clear testament to how specialized engineering using these advanced materials like geosynthetics can provide really significant practical answers to pressing environmental problems, logistical headaches, especially in dense areas where land is just so precious.
So what's the takeaway for you listening? Well, next time you think about urban development or maybe resource management, just consider this. How might these vertical solutions, this clever material science, this sort of out-of-the-box engineering thinking, how might that apply to other challenges, maybe even issues in your own community or your industry? It really brings up an important question, doesn't it? Where else can we build up instead of out to solve tomorrow's problems today?